1990 AB1. A particle initially at rest moves along the x-axis so that its acceleration at any time where t is greater than or equal to 0 is given by a of t equals 12t squared minus 4. The position of the particle when t is 1 is x of 1 equals 3. Okay, so part A says find values of t for which the particle is at rest. Well, you know that the particle is at rest when the velocity is equal to 0. So all we have to do is find the velocity and set that equal to 0. Well, we have the acceleration is 12t squared minus 4. To find the velocity from acceleration, you take the integral of the acceleration dt. So, for this, you take the integral of 12t squared minus 4, and you get 4t to the third minus 4t plus c, where t is greater than or equal to 0. Now, because we're finding where it's at rest, we're going to plug in a 0 to find the c, and since 0 to the third times 4 minus 4 times 0 is just 0, then the c is 0, so it's really not relevant here. So we have that the velocity function would be 4t to the third minus 4t. To find the zeros here, we need to factor and set each piece of the factorial equal to 0. So 4t times t squared minus 1 is the factored form of 4t to the third minus 4t. So if you set 4t equal to 0, you get t equals 0, and if you set t squared minus 1 equal to 0, you get t squared equals 1, so t is plus or minus 1. Now if you go back up here, you remember that we're only looking for when t is greater than or equal to 0. So because negative 1 is less than 0, it's not relevant in this problem. So the velocity is equal to 0, which means the particle is at rest when t is 0 and t is 1. And if you look here, we have a number line, and you can see that two of the zeros are 0 and 1. And there's a sign change, so you know that those would be zeros. Okay. Part B says, write an expression for the position x of t of the particle at any time where t is greater than or equal to 0. So x of t is the position, and to find the position, you're just going to take the integral of the velocity, as you can see here. So if we take the integral of 4t to the third minus 4t dt, then you're going to get t to the fourth minus 2t squared plus c. Now here, the c is important because we're giving, if you look at the original function, we're given that x of 1 is equal to 3. So if we plug in these values, we're going to find the c. So 3 is equal to 1 squared minus 2 times 1 squared plus c. So 3 equals 1 minus 2 plus c. 3 equals minus 1 plus c. So if you add the 1 to the other side, you get the c is 4. So all you have to do is take the 4 that we just found for c and plug it back in to where we first took the integral. So you get x of t, which is the position, is t to the fourth minus 2t squared plus 4, where t is greater than or equal to 0. Alright, finally, part C says to find the total distance traveled by the particle from t equals 0 to t equals 2. Total distance, you're just going to integrate the velocity function. So here, we're going to do the integral of our velocity function, which is 4t to the third minus 4t plus c. And because there's a sign change up here, you can see that from 0 to 1, there's a negative velocity, but from 1 to 2, there's a positive velocity. So because there's a sign change here, we need to split the integral. So we can't just do one big integral, but we're going to split it. So we're going to do the integral of 4t to the third minus 4t from 0 to 1, plus the integral of 0 to 2 of 4t to the third minus 4t. Alright, and just remember that we're going to take the absolute values of this because there is one negative piece, and also because of the negative piece, we're going to have to switch the signs on this first part. So if you integrate 4t to the third minus 4t, you're going to get t to the fourth minus 2t squared. But since this first part is negative, that's why we switch the sign, so you get 2t squared minus t to the fourth. And that'll be from 0 to 1, and then the second part will be from t, so it would be 2 to the fourth minus 2t squared from 0 to 2. So if we're just going to plug these values in now. So if you plug in 1 and 0 over here, you're going to get 2 minus 1. If you plug in 2 and 0 over here, you're going to get 8 minus negative 1, which is 9. So 1 plus 9 is 10. And so that means that our total distance is 10. And here's some graphs for us to look at. The velocity, you can see why we have the negative values over here because it's under the x-axis. And then the position over here. This would be the total distance, would be all of this under the curve. So our answer is t, or is 10, and that's it.